Chapter 1C, Part 2. Here in Example 7, we're going to see how to find quartiles when given a stem plot. This stem plot gives travel times to work, measured in minutes, from 20 random workers in New York State. So in the stem plot, we see the stem is representing the tens place, and the leaf is the ones place. So for example, the 2 here and the 0 here represents a commuter who had 20 minutes commute time. We see there are 3 different commuters who had 20 minutes as their commute time and 1 commuter who had 25 minutes. We see the shortest commute time was 5 minutes and the longest commute time was 85 minutes. This is a random sample, so we're going to treat it as representing the population of workers in New York State and their commute times. Our first task is to find the median. So since there are 20 workers, we know the midpoint is going to be between the 10th and the 11th workers. So here in purple, we've drawn the midpoint. And you can find this by counting up 10. See this 20, and then we know here's the 11th worker, or you can count backwards 10. So either way, by symmetry, we expect the midpoint to be in the middle. You can always take the fact that there are 20 data points and divide that in half. If you divide that in half, you get 10. You know this is an even number, so you know that the midpoint will be between the 10th and the 11th worker. So since the midpoint's in the middle, we think about that median, as we call it, as a fence breaking the data set in half. So you should always have the same amount of data points below the median as above the median. And so the median, since it's a fence between the times 20 and 25 minutes, we take an average. So we calculate the median by saying 20 plus 25 and then dividing by 2, and our median is 22.5 minutes. So in this case, the median is not actually a point in the data set. It's that fence or that divider between the 2 middle points. So we see there are 10 numbers above the median and 10 numbers below the median. To locate the first quartile, that's the number a quarter or 25% of the way through the data set. So we look at the 10 numbers below the median and find the midpoint of that. Now in this case, we've got 10 numbers below the median, so again, that's an even number. Since that's an even number, we're going to go ahead and figure out where the middle would be. So if we take 10 numbers, divide that in half, we get 5. So the midpoint's going to be between the 5th and the 6th number. So again, the midpoint's going to act like a fence. So from the beginning, you can count up 1, 2, 3, 4, 5 data points, and then we draw our fence here between the 5th and the 6th data point. Now in this case, the 5th data point is 15 minutes, 1 and 5 here. And the 6th data point is also 15 minutes, 1 and 5. So when we average 15 minutes and 15 minutes, we get the same value, 15 minutes for our quartile 1. So because we had an even number this side of the median, our quartile 1 is like a fence. In some situations, you'll have an odd number of data points, and then you have one center point that functions as your quartile or your median. To calculate quartile 3, we're going to do a similar calculation. So we know there are, from the median and above, 10 data points. So from the median, you can count up 5 data points, or from the maximum 85, you can count in 5 data points. And we figure that the third quarter of the way through, or the third quartile, is between 40 and 45. So again, this is going to be a fence between 2 numbers. Now in this case, when we average 40 and 45, we get 42.5 minutes as our third quartile. Here's our calculation. So for quartile 1, we average 15 and 15 to get 15 minutes. For quartile 3, we average 40 and 45 to get 42.5 minutes. So now that we know the quartiles, the median, the minimum, and the maximum, we write these numbers in what we call a 5-number summary. So the 5-number summary for these travel times to New York State would be 5 as the minimum, 15 as the first quartile, 22.5 as the median or the midpoint, 42.5 minutes is the quartile 3, and 85 minutes is the maximum. So what the 5-number summary allows us to do is to see the shape of the distribution numerically. So we can look to see from quartile 1 to the median, that's 7.5 minutes. Whereas from the median to quartile 3, that's 20 minutes. So looking at the 5-number summary, we see there's more spread in the data between the median and quartile 3. If we look back up at the stem plot, we see that here from the median to quartile 3, the data is more spread out from 25 minutes all the way up to 42.5 minutes. So it's a further spread or further stretch for the data. And that makes sense because if you rotate this diagram around, you see going from least to greatest, we've got a right skew or a right tail here. So a box plot is a visual way to represent the 5-number summary, and it's useful for comparing two data sets side by side. So here's our New York data right here represented numerically in a box plot. So let's take a minute and analyze this. The minimum is down here. You can draw the minimum with a dot or a little line like this. And sometimes these are called box and whiskers plots because we say the distance from the minimum to the first quartile, this line is sometimes called a whisker. And then the first quartile is represented with the line here. And we see, if we look at the numerical scale over here, it looks like it's about 15. The median is the horizontal line through the middle of the box, and that was 22.5 minutes. So we see it right about here, a little above 20 minutes on the scale. And then the third quartile is 42.5 over here, a little above 40. And then our whisker on the top extends all the way out to the maximum here at 85. So you can also draw box plots horizontally. We'll often let StatCrunch draw the box plots for us when we have a data set. So when you draw it in StatCrunch, there's an option to check or uncheck the if you want it horizontal or vertical like this. Either way is fine if I don't specify. So we want to verify that the New York State box plot numbers agree with our calculations. And we look up here and we see here's the min, here's quartile 1, here's the median, quartile 3, and the max, and they all agree with the numbers represented here in the box plot. So if we go through North Carolina to label, we just have to estimate as best we can, but it looks like the minimum commute time is 5 minutes. Quartile 1 is 10 minutes. The median commute time is 20 minutes. Quartile 3 is 30 minutes, and the max up here is 60 minutes. So when we do a side-by-side comparison, we call the space from quartile 1 to quartile 3 the central box. So if we do a side-by-side comparison, it looks like the central box in New York is bigger, and we definitely see more of a right skew because the numbers go from least to greatest. So if you rotate your head, you see it's got a skew to the right in New York. North Carolina looks like there's a little skew at the end, but the central box looks pretty symmetric. So if we want to analyze which state has a higher median, we can just do a quick eyeball check and see that New York looks like it has a higher median. And similarly, if we want to know which state has a lower first quartile, we see North Carolina down here has a lower first quartile, right? The first quartile is the start of the box. And then the inner quartile range is thought of as the distance between the first and the third quartiles. So this is sometimes described as, a typical range or where we might expect to find values in this central box, right? Because the outliers would be the min or the max, so the central box wouldn't contain any extreme values. So sometimes we look there for typical or usual values. So for North Carolina, the inner quartile range, or IQR for short, is 30 minus 10 or 20 minutes. And you can see that here, from 10 to 30, that's 20 minutes in there. For New York, if we take our quartile 3, 42.5, minus quartile 1, 15 minutes, we get 27.5 minutes. And with our side-by-side comparison, we do see that the central box for New York looks a bit bigger than the central box for North Carolina. So we say New York has greater spread from the min to the max, and the range here is 85 minus 5 or 80 minutes. So the range is the distance from the max to the min, so you can say max minus min, or you can think about it as going from the minimum value here up to the maximum value here. Range is one way that we measure spread. We'll see later on this semester. We can also measure spread by how much the graph is stretched or compressed. So if we want to draw our own box plot from the 5-number summary, if we want to do it by hand, we can start with our 5-number summary. So we've got 57, which is the min, 74 is quartile 1, 79 is the median, 87 is quartile 3, and 96 is the max. So if we want to know which number is the median, we can say right away that's 79, first quartile is 74, third quartile is 87. So I'm going to use the median, quartile 1 and quartile 3 to sketch my central boxes. So when I do this on a scale like this, I just do the best I can. Here's exam 1 here in green. So I went to 79 just below 80 and I tried to draw a line through there for the median. And then I drew a line right around where I thought 74 would be. And a line right around where I thought 87 would be. And then I connected the sides to make the central box. And then for the min, I came down to 57, or right around where 57 would be, and I put a little line or dot there and extended that whisker back up to the dot, to the box. And then I did the same thing. I estimated about where 96 was and extended the whisker there. Let me show you in StatCrunch. So if you want to go in StatCrunch and open a new window. In StatCrunch, I've typed in the exam 1 5-number summary in a new window. And we see we can go to graph, box plot, and I choose exam 1 5-number summary. And I want to draw my boxes vertically, so I'm going to leave this unchecked. And we click compute, and here's the exam 1 5-number summary. And I saw I made a typo here. The second list is the exam 2 5-number summary. So to edit in StatCrunch, you just click in the name you've given and edit your typing there. And we see my exam 1 5-number summary looks very similar to the graph that I drew. Maybe this one's a little more accurate. So now we're given the 5-number summary for exam 2. The minimum is 62. The maximum is 90 over here. Quartile 1 is 70. The median is 75. And quartile 3 is 83. So again, I did my best to draw those points in here. So you put a dot or a small line where the minimum is. You put a horizontal line through quartile 1, the median, right there at 75. Quartile 3, that's about 83 by my drawing. And then you put a dot or a small line at the maximum. You connect up the central box and extend what we call the whiskers out to the minimum and the maximum. So in StatCrunch, if I head over there, I can go to Options, Edit, and I can hold down Command or Control, depending on if you're on a PC or Mac, and also click Exam 2 5-number summary. And here is my side-by-side comparison. So it should look pretty similar to what I drew by hand. A little bit better in StatCrunch. In StatCrunch, if you prefer to have the boxes drawn horizontally, remember there is that box here to check draw boxes horizontally, and you can say compute. And here we go like this. So it might be easier to visually compare horizontally. Now we see here the median's right in the middle, and notice if I hover my mouse over the box plot, I get the full 5-number summary. So if you have a full list of data and not the 5-number summary, this is a quick way to compute the 5-number summary. Let StatCrunch do the math for you. And again, I can hold it over the other exam to see the 5-number summary there. Now we know the median is right here through the middle, so if you go to Options, Edit, you can put in a marker for the median in red. That should go right through the midpoint of each box. And then if you want to see the mean, you can check the mean box, and that'll put a green line through there. So we see here in exam 1 down here, the mean and the median are pretty close. And here the mean's a little bit lower than the median, which explained by this slight left tail we see here. And then in exam 2, the mean, the green line's a bit higher than the median, which is explained by the slight right tail here. So you can always use technology to recreate the graphs, and then you can attach a printout or do your best to sketch. So if we want to know which exam had the smaller interquartile range, we can do the calculation. So for exam 1, quartile 3 minus quartile 1, 87 minus 74 is 13 points. And for exam 2, 83 minus 70 is also 13 points. So both exams have a 13-point interquartile range. And if we go back to the StatCrunch graph, we see it looks like the central boxes are very close in shape to each other. And if you want to do the vertical comparison, just uncheck, draw boxes horizontally. I'll uncheck the mean and the median, and we can adjust and see it does look like the boxes are about the same width. So here in example 10, we're going to see how to find suspected outliers. You might have noticed in the StatCrunch option, go to Options Edit, one of the choices was to use fences to identify outliers. So that was checked here. Since we didn't see any fences to show outliers, in this case we didn't have any visual outliers. If you do leave this checked, StatCrunch will show you the outliers with dots. So let me show you what that would look like. Suppose I change the min for exam 1 to be a score of 20. And then I go to graph, box plot. I do exam 1 and exam 2, and I use my fences to identify outliers. Notice now there's a dot down here at the score of 20 and no whisker out here. So that's telling us it is an outlier down there, an extreme value. So outliers are represented by dots in StatCrunch if you leave that option checked. So here's again the 5-number summary for travel times to work in New York. And so we can compute the interquartile range. We know 42.5 minus 15 minutes is 27.5 minutes. And then to determine if a value is an outlier, our rule of thumb is to first calculate 1.5 times the interquartile range. So we'll multiply 1.5 by the 27.5 that came from the calculation in Part A. And we get 41.25. We think about this as our buffer or our area that we're going to add and subtract from the quartiles. So we take this 41.25 buffer zone and we add that to the third quartile. So the third quartile was 42.5. We add our 41.25 that came from the calculation in Part B. And we get 83.75. So that's the upper limit for an outlier in this data set. So were there any travel times above this? So we know that there was an 85-minute commute time if we go back to that stem plot a couple questions back for New York. So this 85-minute commute time we can now classify as an outlier based on this criteria where we multiply the interquartile range times 1.5. Now we're going to check for lower outliers. It doesn't look visually like there are any lower outliers, but let's go do our calculation. So to check for a lower outlier, we take our quartile 1, 15 minutes, and we subtract the 41.25 buffer zone that we've calculated. That came from this calculation up here in Part B, 1.5 times the interquartile range. We get a negative 26.25. We know there are no negative commute times, so in this case there's no lower outlier. That matches what we saw in the graph because it didn't look like there was any values far out on the lower commute times. We say since there are no negative commute times, there are no lower outliers. Anytime you're checking for outliers, you're going to go through that interquartile range times 1.5 calculation. That's our buffer zone, and then add and subtract that from the quartile 1 and quartile 3 to look to see if there are outliers. Here's a histogram, and in this histogram, we're told that there are 224 countries here, and they're measuring infant mortality rate. So in this case, a lower infant mortality rate would mean children are surviving, and that would be preferable for a country. A higher infant mortality rate, this is per 1,000 live births, would be worrisome for the country. So we see a strong right tail here, which tells us most countries have low infant mortality rates, meaning they have good healthcare in place. So this is for 224 countries. And notice here that the y-axis, instead of being a frequency count, is a proportion. So they took the total counts and divided by 224. This is called a relative frequency. And so here, what we want to do is estimate where quartile 1, the median, and quartile 3 would be. So we know there are 224 countries. And we know that these heights of the bars should total 1 or 100% if we wanted to translate our decimals to fractions. So for example, our decimals to percents. So for example, this 0.36 would be the same as 36% of the countries and the bar from 0 to 10 infant mortality rate. This 0.22 would be 22% of countries and the bar from 10 to 20 infant mortality rate. So we know the median's halfway. So the median, if we do 224 divided by 2, that's 112. The median's between the 112th and the 113th countries. So if we had a straight count here, we would count through to try to figure out where we were between 112 and 113. This is also the halfway point. So we want to look to see where the relative frequency is going to be half or 0.50. So I estimated the first bar right around 0.36 height. See, here would be 0.35, so I counted a little above. And then I estimated the second bar, since it's a little above 0.2, about 0.22 frequency in the height. So if I add these up, I'm going to get a total over 50%. So I know then the midpoint, the 50% way through, or 0.50 relative frequency, must be between 10 and 20 in here, because the total of the bar heights is 0.50, somewhere in there. So from 0 to 10, the relative frequency would be approximately 0.36. From 0 to 20, that 0.36 plus 0.22, the relative frequency is approximately 0.58. So the median is between 10 and 20 infant mortality rate. Now we want to identify the quartiles. So the first quartile is a quarter of the way through the data. Well, the first bar holds 0.36 or 36% of the data, so we can say with confidence that quartile 1 is between 0 to 10 infant mortality rate. So now we got to try to figure out where is 3/4 of the way through. So I kept on estimating, and you can see if you add from 0 to 40 the bar heights, 0.36 plus 0.22 plus 0.11 plus 0.05, let's see what we get. This gives us 0.48. This extra 0.11 gives us 0.59. No, this is 0.58. This is 0.69. The 0.05 takes us to 0.74. So from 0 to 40, if we add all this up, we get 0.74 relative frequency. All right, well, from 50 to 60, I estimated that to be, or from 40 to 50, I estimated that to be about 0.06. So then we can say from 0 to 50 infant mortality rate, 0.74 plus 0.06 is 0.80 relative frequency. So quartile 3, 75% of the way through would be 0.75 relative frequency. So we can say quartile 3 is between 40 and 50 infant mortality rate, somewhere in here on the histogram. We can't say exactly, but we can do a pretty good estimate using our best estimates for the heights of these bars. Now, what would you expect about the relationship between the mean and the median in this data set? I think we agree there's a strong right skew, which tells us most countries have low infant mortality rates, and a few countries have higher infant mortality rates. So when we have the right skew, we expect the mean to be higher than the median. We can call the right skew a right tail. Either way, we can describe that relationship with the data pulled out in the direction to the right. So in this case, a few high values, a few countries that have high infant mortality rates pull the mean up.